Now let's look at the last question on our topic test, and this is actually a question from the 2020 HSC. A cricket is an insect, etc., etc., etc. Now, there is so much here in the question that you need to read. So the hardest thing about this question is not the maths that you have to do, it's working out what maths to do. So I can't write the question out. You'll need to have it in front of you right now, because otherwise it's going to take up my whole whiteboard. But what I've done here is I've listed the important parts of the question. So I'd like you to take a highlighter or a pen to underline things, and let's just actually cut to the chase and see the important parts. Now, the first important bit when you're just reading it is to almost imagine acting it out, so you've got an idea of the scenario. A scientist is basically going out once a day for 20 days, but each time they go and, take their little sample, they only listen for 15 seconds and they just count how many chirps they hear. And then they write down that number for that day, and they write the temperature that it was that day. So that gives them 20 different samples. Now, the first thing that you've got there is a box plot. That's the first important part. Now, what does a box plot tell you? It tells you the lowest score. So one day he only heard 13 chirps, one day he heard 27, and every other day it was something in between. It tells you the Q1 and the Q3 and the median. This is the important part here, the median. Now, how do we know it's important? Well, the next sentence underneath says the mean temperature in the data set is 0.525 degrees below the median. So your first question should be, well, what's the median? Oh, hang on, I know the median. It's 22. So over here, let's write down important things that we've worked out from the question, because that's how I'd start. As I read through and highlight things, I'd jot down important points below that I think I'm going to need to use. So they've implied that I need to work out the mean, and they've said it's a little bit below the median. What is the median? Well, let's write down some things that we know. The median temperature is 22. So that means that the mean temperature must be 22 minus 0.525, which is 21.475. So that's the mean. All right, altogether there are 684 chirps. That's important, highlight that. And there were 20 data points. Okay, so could we work out the average number of chirps per day? Sure. How would we do it? Well, 684 divided by 20. So we've got the mean temperature. We can work out the mean number of chirps as well. Okay, so we've got to do 684 divided by 20, and that's going to give you 34.2. So now we know the average temperature was around 21 degrees. We've got it exactly. And the average number of chirps that we heard was 34.2 chirps. Okay, what are we going to do with that? Well, they tell us here that they've got a least squares regression line. That's a line of best fit using the data X and Y, where X is the temperature and Y is the number of chirps. Now that's important. At this point, I would even just do a tiny little 2-second sketch where I say, okay, so temperature is down here and chirps is up there. And obviously the scientist is seeing whether the temperature actually affects the chirps. Okay. Now, they've given us the line of best fit equation here. Now, the one thing we don't know is the gradient. We don't know the gradient of the line, but we do know the y-intercept because this is in the form y equals mx plus b. And confusingly, there's a b in here, and they've told us that the b is the slope. So this must be the y-intercept. Does that make sense? It's like it's in the form y equals y-intercept plus mx, except they've called it bx. A little bit confusing. Okay, so if the y-intercept is actually down here at, say, minus 10 and a bit, then we've got some kind of line that goes up like this. Does that make sense? Now, if the slope is positive, and I'd say it would have to be because you can't have a negative number of chirps. So obviously the line doesn't really make sense down here, but notionally that's where it goes. The chirps must all be up here, like this, and we've got some sort of line going through them. So now I've got a bit of a sort of understanding of what's happening. Now the next important point is they mentioned that this line of best fit, or this least squares regression line, actually passes through the mean of the x's, so that's the mean temperature, mean of the y's. That's a super important point because we know that point. We've actually already figured it out. So we know that x bar is the mean temperature, and we know that y bar is the mean chirps. And we know that because we have the average for each one, and we've been told what's on the x-axis and what's on the y-axis. So it's just a matter of picking out what's in the question and making sense of it. All right, if you know a point on the line and you know another point on the line, is that enough for you to figure out the equation of the line? Absolutely it is. So if we can figure out the equation of the line, then we'll just have to plug in x equals 19, what's y, so that we can get an estimate for how many chirps you might be expecting to hear if the temperature is 19 degrees. So a couple of ways we can do this. First thing I want to do, I think, is find the gradient of this line. So if gradient is rise over run, then we need to do y2 minus y1 over x2 minus x1. Now here, a little sketch is handy. You know that this is 21.475, 34.2. And this point down here is 0 minus 10.6063. So here in your working, you're going to go 34.2, whoops, 34.2, that's a really big decimal point, minus this y value. And if you're subtracting minus 10, that's like adding, over, what have we got, 21.475 minus 0. Chuck that into your calculator and you will get the gradient, which is 2.086, goes on and on, etc. So you could round that off if you like to a good number of decimal places. Now, I would actually then store that number in my calculator by hitting the shift store and then call it red A so that I can use it later on and it's going to be exact. All right, so now I've got the gradient. I can basically do a better version of this line of best fit. The line of best fit now is minus 10.6063 plus, this is my gradient, to, let's say 2.1, but we'll keep the exact version of it in there, x. All right, so now I need to just solve when x equals 19, y is going to be negative 10.6063 plus 2.1 lots of 19. Sorry, that's a little bit messy. So I've got my numbers stored in there, or perhaps it's still already on the screen. I need to just multiply it by 19, subtract 10.6063, and the number that you're going to get is 29 point something, quite small. I had 0.036 and I did it exact, and that went on and on. Now, rounding to the nearest number of chirps, I'd say, therefore, we expect 29 chirps because we're just going to the nearest chirp. So the actual maths in here, finding the gradient of a line, that's not that hard. Finding the x bar, y bar, like that actual point, well, finding the mean temperature wasn't very hard. We just had to take the median. We had to know that that is the median and then just do what we were told with it. And then finding the mean number of chirps, dividing this by this in itself, not very hard. But putting it all together and making a plan and knowing how to execute it, that's the tricky bit. Also, not getting put off when you see all of this text and just going, oh my gosh, I don't know what to do. You need to just work through it, write down what you know, and the more things that you write that you know, the more you realise that you know enough to make the plan for the next step. I think this little sketch is also really handy because it gives me that feeling of what is it that I'm trying to do here? I've got a point, I've got another point, I'm trying to see how slopey it is, I'm trying to get the equation of the line, I've got it, but it's not very good because I'm missing some of the detail. I don't know what the slope is. And then away you go.